while electronic devices and systems could sustain permanent damage. These cascading failures would highlight just how interconnected our world has become and how dependent we are on the technologies that the magnetic field helps protect. In the next part, we'll take a closer look at how the natural world would respond to such a sudden flip, including the potential effects on wildlife and the environment itself. A sudden and complete flip of the Earth's magnetic field would profoundly disrupt the natural world, creating challenges for both wildlife and the environment. Many species have evolved to rely on the magnetic field as a guide for survival. This natural compass is deeply embedded in their behaviors, and its sudden reversal could leave them disoriented, leading to widespread ecological ripple effects. Migratory animals such as birds, sea turtles, and certain species of fish are particularly vulnerable. These animals use the Earth's magnetic field to navigate vast distances during migration, often traveling thousands of miles between breeding and feeding grounds. For example, sea turtles rely on magnetic cues to return to the exact beach where they were born to lay their eggs. A sudden magnetic flip could confuse these animals, causing them to lose their way and fail to reach critical habitats. This disorientation could disrupt breeding cycles, reduce population numbers, and threaten the survival of species already at risk. In the oceans, marine life dependent on magnetic navigation would face similar challenges. Some species of sharks, which use magnetic fields to hunt and navigate, could struggle to find food or migrate to their usual areas. Fish populations could shift unpredictably, creating imbalances in marine ecosystems and affecting the fishing industries that depend on them. Coral reefs, which support a diverse array of marine life, might also suffer indirectly as disruptions to the food chain ripple outward. Terrestrial animals that use the magnetic field for orientation, such as certain mammals and insects, would experience confusion in their daily behaviors. For example, some species of ants and bees, which rely on magnetic signals to find their way back to their colonies, could lose this ability. This disruption could affect pollination patterns, with cascading consequences for plant reproduction and agriculture. Beyond wildlife, the environment itself would be exposed to increased solar radiation during a magnetic field flip. The weakened magnetic field would allow more charged particles from the sun to penetrate the Earth's atmosphere, leading to changes in atmospheric chemistry. One immediate consequence would be damage to the ozone layer, the shield that protects life from harmful ultraviolet radiation. An increase in ultraviolet exposure could harm plant growth, particularly crops which are sensitive to changes in radiation levels. This could result in lower agricultural yields and exacerbate food shortages already strained by disruptions in technology and logistics. Regions closer to the poles, where the magnetic field is weakest during a reversal,